El siguiente ponente es Nacho.
Now we're going to listen to Nacho. Is coming from ProDevelop, Nacho Brodin. They all know me because I've been here before. Yeah. So you're a fan, you're an idol already. So he's going to talk about the automatic system for the detection of environmental changes.
Está muy bien. Vale, pues nada, voy a hablaros sobre el proyecto ENACDES.
So I would like to talk about the ENACDES project. It's an R&D project. It has to do with the automatic detection of changes. So I will try to be very quick. So this is a bit what we are going to talk about. The participant, the objective of the project, the development lines, the problems, the behavior. It's a project that is still under development. So I will show you a few conclusions, but the project is still an ongoing project. So we'll have a look at the film that's being made on it, but in another occasion. So the participants are ProDevelop, the CGAT group from the Polytechnic University that have been financed by ERDF funds of the European Union. We have the collaboration of different companies, of different universities, and well, you see their logos here on the slides. So the objective of the project is to develop some algorithm set for the automatic detection of changes. We are comparing dates and raster information to see the changes. Those algorithms are well defined and they are very widely used in the university, and it's giving an added value to the project. So we have defined a series of scenarios, for example, forest fires and water areas, and to make sure that the user has the possibility to detect, well, the kind of areas that he wanted to study. So we have been working with different work resolutions, and it's led to a series of problems that I will describe later on in my presentation. And obviously we've been using gvSIG. This is why we are all here. So I will show you a little clip with the tool. But first I have to explain a series of things so you won't be able to understand the tool. So first, we have started from the beginning, from scratches. So we have been detecting changes with the pixel level, from the pixel level, and we've been using, well, those tools like, for example, the change reader. This is what we've been using at the beginning. And in the clip that you will see, well, it is related to that change reader. We have also been using the Landsat TM images, and we have been focusing on very concrete study areas. And now I will show you a few images so that you can understand the tool much better. On the left, you see more red dots, and on the right we have less dots. These pictures have been taken at different days. We have here the different crops. So what's really happening? We are comparing areas that we know, we extract some samples and we analyze them. It's a bit complicated, but at the same time it's very simple. So you analyze an area. You see that here we have no building. Here we have buildings now, 2 different days, 2 different situations. So we see the changes, and I put a red dot if there is a change. So my algorithm will read the changes and will produce a result. So we have a distance layer to see the difference between, well, the origin and the final situation. So for this area, it is generating a transition value. And for the areas with no change, well, I see that there's no change because I put a blue dot. So the red dots represent the changes and the blue one the areas that have not experienced any change. So I see it visually, it's very easy, and with that graph I can analyze if I have experienced a change or not. So it's very easy to see it if I have a built or a non-built area, if I have a transition between one situation or another. We see it here thanks to this color code table. But if you take one of those clouds, well, you see it's very difficult to divide the red and the blue dots. So it's not an easy analysis, but this is, well, the main components methods. This is a method that we've also been using. It is decomposing the different images. It is breaking down the results. So we have those stains, and from the original situation we have been doing this sampling, comparing, well, the two results. We are comparing component 1 with component 2, component 2 with component 3, and so on and so forth. So the algorithm are behaving well with some changes and are not behaving that positively with other changes. And we see the different urban and rural areas. Here we have decided to develop a tool for gvSIG for this change reader. It is generating the transition and evolution layers and the scattering layers, and we are going to see that in the clip in a moment. So here we have two images, Landsat images, one in May 2002 and the other one in August 2002 too. So we have a difference of a few months. So we are working with different bands, 3 and 4. We select the two images. We can load the bands separately, or we can include them at the same time in the same image. If I say OK, well, it calculates the distance layer and the orientation layer. And we see the scattering cloud there on the image. There's no red or blue dots here. What we see here, thanks to the algorithm, is the transition areas and the non-transition areas, obviously. So the parameters have been set previously. We can do it manually too. We can select manually too. And we see there in the view box, well, the transition area. Say, for example, we have selected the water changes, and we see the changes that have occurred. Here, for example, we have the Albufera Natural Park of Valencia, and we see a synchronization between the view box and the gvSIG view. We can adapt one language to the other and vice versa. And so once we have adjusted the parameters, well, we can generate the result. The result is a layer, is a mask telling us what are the changes in that area. We are generating it in raster. We get some statistic, the surface of the area of changes, the number of zoning and of polygons. The polygon layer, we've had some problems that I would like to share with you. Well, I don't know what time I have left. Please give me that information about my time left. So with vectorization, we've had some problem. We have tried to use the sextante vectorization, but unfortunately we had some problem. So these are the results to vectorize the raster layer. We've made some comparison with those images, but it's not very clear, so I would like to share with you the problems. We have generated a vectorization algorithm. On the second one, we have type B polygon vectorization, and on the right, well, it's not saying anything, but really, well, what I would like you to see is that, well, the result between the two is very different. You don't see any island. The size of the polygon is not real. We don't see any hole, any gaps in the image. So it's the one in the middle that we are implementing, solving all the problems on the other algorithm. It's true that it's type B in red and black, the format that's giving the best representation, but they are left pixels, so it can also cause some problems, and it is generating only one file, and it's very difficult to specify the value that you want to transform into polygons. We have some problems with big images too, but anyway. So finally, well, the yield, the performance was not very well with polygon A. So finally, we have decided to generate a polygon per value based on the value, and it was working much better. So now we have some problem with the resolution. It's not complying with the initial requirements because it's not working with high definition images, especially in urban scenarios. Because of what? Well, because of different factors. When we increase the resolution, if the image is not well rectified, well, then we have some deformation. We have different spectral responses, and the result is like the one we see there. It's very difficult to separate the transition and non-transition areas. It's very difficult to have a function to separate the information, and we have a mix between red dots and blue dots. They are merged. It's very difficult. We need a check to try to filter the result. It's very difficult to separate buildings, for example, in a high definition picture, and it is a true problem. We have possible solutions at hand. Well, this is exactly what we are going to do now. We are going to work on that. We can also extract, well, the natural areas to only keep the urban areas and water areas too. We can separate wood. So we are trying really to limit the urban areas, not to have too much interferences. And we will also try different methods, because the final objective is to have an assistant that will help us to select the type of image, the resolution, the scenarios, so that it will detect which algorithm suits better our environment, and to get at the end, well, the best result as possible, adapted to the original image. Well, this is a bit what we are doing now. We are trying to develop that. Well, I've tried to be as quick as possible. I hope that you have understood everything. Thank you very much.